in the Pub event with an acknowledgement of country. I'd like to acknowledge the Nguyen people upon whose land we're standing tonight and who have been the custodians of Lucha for generations, centuries. In particular today, I'd like to acknowledge their women. I want to acknowledge their suffering as their loved ones were murdered and their lands were taken. I'd like to acknowledge their strength and their resilience in being the holders of knowledge. Along with that, I'd like to acknowledge all of the women here tonight because this is International Women's Week. I think it goes on for a week, it's not just a day. So I'd like to hear a round of applause for all of our women here tonight. Thank you for all you do for yourselves, for your families, and for your communities. This week is about celebrating women, and we couldn't do that without the help of our wonderful men and non-binary people. So thank you guys for being champions of change and supporting diversity and inclusion in our community and in science. So a round of applause for our non-women here tonight. All right, so with that, I'd like to see a show of hands. Who is a regular Science in the Pub or has been here before? Yes, welcome back. Thank you guys for coming and being our supporters. So raise your hand if you're a newbie to Science in the Pub. Okay, welcome. You guys can come anytime. We're here the first Thursday of every month. The way this works, for you who have never been here before, is it'll be similar tonight to how we normally do it. We have 3 speakers on a similar topic. And each of them talk to their expertise for about 10 or 12 minutes, and then we have a panel discussion at the end. You can ask them whatever questions you have. There's usually time for 1 or 2 questions as we transition between speakers as well. It's an informal event, that's why we host it in a pub, so go ahead and get yourself a drink. At some point soon there will also be nibbles, usually before we get started, but when they come out they are delicious and hot, so actually maybe give them a couple of minutes to cool down so you don't burn your mouth with the grease, but help yourself to those free hot nibbles when they come out. Bathrooms are behind me, and yeah, do as you need to. If there's ever a term that you don't understand or you have a question during the talks, do feel free to raise your hand. These guys are pretty good communicators. They'll be able to manage and be nimble with their presentations. Okay, so you probably saw Tessa walking around with raffle tickets before the event. Science in the Pub is a non-profit, volunteer-run science engagement organization. We exist to connect the incredible scientists that we have here in Tasmania with the incredible interested public, and that's you guys. So we do that by hosting a free event here the first Thursday of every month. And the way we sustain ourselves is through donations and some sponsorship. So I'll thank our sponsors in a moment. But yeah, if you buy raffle tickets, that's one of the ways that we support these events and are able to give free hot nibbles and free drinks to our panelists, which just makes them more comfortable and friendly. So keep it going. We also have surveys, so I'll hand those out at the end. And if you fill one of those out and hand it back to us, you get entered in a prize draw for $25 to the pub, just for handing back a survey. And that's a great way to let us know about people you'd like to hear from in the scientific community, or topics that you're interested in, or just any feedback you have, including get your audio stuff together, because yeah, that's fine feedback for us too. So I'm going to thank our sponsors, and then I'm just going to introduce the Inspiring Women in STEM program that's supporting the fellows here tonight. So our sponsors have been Instrument Choice, and local businesses including Barilla Instrumentation, Inspiring Australia, and of course the Black Buffalo. So, all right, so our presenters tonight are our 3 fellows from this year for the Inspiring Women in STEM program. And we started this because a higher degree in STEM can also be a springboard to a rewarding career and an opportunity to give back to one's community. However, women are often underrepresented in STEM careers, and especially women from remote, low-income, indigenous, or minority communities often face additional barriers to achieving employment and education in STEM fields. So I'm just going to share with you some stats to back up that sentiment. This is from the 2020 report on Australia's STEM workforce, put out by the Australia's chief scientist last year. So of the 23.4 million people that make up the STEM workforce in Australia, women comprise 47.5% of that, so relatively even gender parity there. But as far as the STEM skilled workforce, women only make up 16%. There we go. And that percentage declines as you go into the higher echelons of leadership in the STEM fields. So you have relative gender parity at the lower levels of leadership at the top here, and as you go up, that declines. And in the highest levels of leadership, for example, CEOs or heads of businesses, you've only got 8% women in those roles. And that matters because generally STEM fields pay relatively well, but women get paid 23.7% less than men in STEM fields. So why is that? Why are we losing these women as they progress through their career in STEM? Well, there's been some research on that, and there are a lot of reasons why there's what's called the leaky pipeline effect, or why women are excluded or drop out of the career pathways here. And it's the factors pushing women out of these STEM careers differ across different stages of STEM careers. And there's a lot of different factors contributing to that. There are biases and stereotypes and harassment and discrimination that women face. But I wanted to highlight along almost all of these career stages where women are dropping out, something that's been flagged as a lack of mentorship and a lack of role models. So this is sort of known across all fields, but you have to see it to be it. You have to see yourself in a certain position to know that you can achieve it and to feel capable and confident to go into those roles. And that's the case for women in STEM as well. So if they're not seeing themselves in those leadership positions, not seeing women in those roles, it's harder for them to imagine themselves in them and harder to stay with that field. So that's part of the reason we started the Inspiring Women in STEM program. And I'll mention it more in a second, but first, why should you care and why should you support this program? There's a lot of good reasons. Most of us feel like intrinsically inclusiveness and diversity are a good thing, but there's also a lot of evidence to back up why diversity and inclusion and gender parity are good things. So it's good for our economy. This report is demonstrating how addressing gender equality can have incredibly beneficial effects for our economy. And also for men in the audience, I know it is sometimes hard being a man to support women's issues, but many of you do it, and we thank you for doing it. And there are good reasons to do it. One of them is that supporting gender equity in society doesn't just benefit women, it benefits men, it benefits their happiness and their well-being. Men who don't feel forced into stereotypes and are in a culture that accepts people doing as they wish and without being forced into stereotypes. It makes men happier and women happier. So it's good for everybody, is my point here. That's why you should support these sorts of initiatives. So this one in particular, the Inspiring Women in STEM program through Science in the Pub, provides funding for the Inspiring Fellows to deliver STEM engagement, mentoring, and education for youth in their community. As part of the program, the fellows receive training to hone their research story and maximize the impact of their presentations for girls in their community. And they're also connected with some media opportunities and a supportive network of other amazing researchers in Tasmania. And of course, the winners are invited to present at a Science in the Pub event like this one. So the grant seeks to lift the profile of some of the incredible young female scientists in Tasmania and amplify their voices so that they can inspire the current and next generations of women in STEM. The inaugural grant was supported by funds from the Vice Chancellor's Award for Outstanding Community Engagement, awarded to myself and Andy Fleece in 2018. The second year that's supporting these ladies that you'll hear from tonight was supported by generous donations from the community. And as we celebrate the second cohort of Inspiring Women in STEM, we are starting our fundraising for the next round of Inspiring Women for later this year. So I will send out a link to everyone that's registered tonight. If you're in a place to support and you would like to do that, by all means, please do. But if you just want to be here in spirit and support us in spirit, that's okay too. All right, with that, I will introduce our speakers tonight. So normally I do a relatively long bio for the presenters, and I talk about their pathway to their current position in the university or in whatever career they're doing, and what they like to do outside of work. But tonight, they're going to talk to you about all those things. So I'm doing a very brief introduction. First tonight, you'll hear from Nguyen. She's a PhD candidate in the School of Natural Sciences, studying the distribution of plants across volcanic forests of Australia. Next up, you'll hear from Neka Orji, and she's a PhD student studying health economics in the Menzies Institute for Medical Research. And she's currently going to be joining us via Zoom from Nigeria. So she's not been able to travel to Tasmania yet, thanks to COVID restrictions. We're hoping she can come here sometime soon, but we will rely on technology to get her here tonight, and hopefully that works out. And last but not least, we'll have Ali Dove, a PhD candidate in the Institute for Marine and Antarctic Studies. Marine and Antarctic Science? Studies, okay, in IMAS. And she's studying the ecology and feeding behavior of seabirds, including little penguins and muttonbirds of shearwaters. Can you join me in welcoming our panelists tonight?
Thank you very much for your patience. So, thank you for being here this evening and supporting us. The topic is Women in STEM, inspiring women in STEM, and inspiring women into STEM. Why do we need to talk about inspiring women into STEM in the first place? To begin with, as Emily said from the Chief Scientist of Australia, in 2016, Australia's population was roughly about 24.2 million. And of that, we have about 11.5 million in the workforce. But of that 11.5 million, we only have 2.3 million who work in STEM. And what you see is that only 16% of that is actually women. And okay, so what we're seeing is only 10% of that actually go on to bachelor and beyond. And of those 10%, not a lot of them are actually making a lot of money in the top income bracket. So I'm obviously not going to be sitting on a giant pile of money anytime soon. So why do I do it then? Why do I get into STEM despite all of the odds? I do it because I get free hugs from trees. This one had no choice. I do it because I love science and I love nature, and I would like to inspire more women to be able to chase their dreams of getting into science as much as possible. So, by now you're probably wondering, so who is this person in front of you? So you guessed by now that I'm a female scientist, hurrah. But if you ask me, I'm just a professional tree hugger. I'm currently at the University of Tasmania doing my PhD in the ecology of volcanic forests. But before I talk about my work at the University of Tasmania, I'd like to take you on a journey, how I came to the University of Tasmania. So I started at the University of Queensland doing a Bachelor of Arts and I majored in archaeology and geography. And because I really enjoy looking at patterns in nature, trends and processes in nature more than I did looking at why civilizations are crashing, I went on to do my honours in Timor and did my honours in geography. And I had to battle some crocodiles along the way, but a paper came out of that, and this was in palynology. Then I went on to do my master's at the University of Melbourne, also in palynology. And so you're wondering, what is palynology? Palynology is just the study of spore pollen and organic material that is left over in microscope slides. So first you go out into the field, and luckily this second site didn't have any crocodiles to avoid. But it was a vertical cliff and didn't die. Then I collected samples along, the idea is that the older layers are on the bottom and then it gets younger as we go up the cliff. And then I take these soil samples back into the lab, and then I get this really cheap spacesuit to protect me from really harsh chemicals like hydrofluoric acid. So hydrofluoric acid is such a harsh chemical that if you breathe it in, you'll probably die. If you touch it, if it gets on you, you'll probably have to amputate it and probably die. So it didn't lose any body parts, yay. And then whatever is left after I've dissolved all the soil and mineral component, I get left with these organic material left on the microscope slides. And from the spore pollen grains, I was able to reconstruct the past environment. So what you'll see is, for example, fern spores will allow me to reconstruct tree ferns. And Myrtacidites is an extinct species, and we use nearest living relative to associate that with living versions of Myrtaceae. And again with Dacocarp, this is not a podocarp. So Dacocarpus belongs in the podocarp family, but I didn't have a podocarp tree, so this is an Araucaria. But you get the point, so I get to reconstruct past environments. And the idea was basically, the Earth has gone through phases of really warm and cool phases, massive swings in Earth history. And we're heading towards a really warm phase. And I really wanted to see what had happened to the plants during the extremely warm phases of Earth's history. The moment that I submitted my thesis, I started applying for jobs madly. And within 2 weeks, I got an internship at Geoscience Australia. And then there I continued on to be a research assistant at ANU. And this was where I was first introduced to Python, GIS, remote sensing. And this is a completely different field to where I was before. So you've seen me as a lab scientist with a lab coat, with a microscope, battling crocodiles, but now you get to see me as an uncool hacker. If you imagine, Python is a language that allows us to communicate with the computer in order to do mass simulations. So at Geoscience Australia and ANU, I was introduced to Python and I was introduced to GIS and remote sensing. And this was where I did a lot of really meaningful work on predicting how much of the stress is in the Earth so that we can predict how much stress is left over that needs to be released. So predicting earthquakes. And that resulted, that work, I was only working at ANU for a year, but then I continued to volunteer for several years, so there's a 4-year gap there. After ANU, the project ended because there was only a year's worth of funding, so I continued to work on that as a volunteer. So after ANU, I went on to being a data analyst for a company. One of our clients was Bunnings, and so I worked at analyzing data for Bunnings. So like, why does company A sell more lawnmowers than company B? And I only worked there for about 8-9 months, and my soul was crushed. And then I had an identity crisis, and I thought, this is not for me. I'm not cut out for the real world. I'm not cut out for analyzing lawnmowers. So that was when I packed my suitcase, and I went on what I call the Great Wandering Years. So the Great Wandering Years was about 4 years of me living out of a suitcase. And I essentially wandered around wondering about, is chocolate really better if it's made by the Swiss? Where are the prettiest mountains? And you know, what makes a meaningful life? Because obviously making a lot of money was not making me happy. And so I naturally went to Switzerland first. Ate a lot of chocolate. And then I went on to a number of other countries. And when I got to Germany, I landed a gig for freelance English teaching. And I basically just taught children how to toss a boiled egg out the window using maths and physics. And then they get to eat the egg if it's not splattered on the concrete pavement. And I really enjoyed teaching. I really enjoyed teaching English to young German children. And so I ended up staying there for a year. And some things I learned. Awesome. So some things I learned is that, first of all, I'm a terrible suitcase packer. What I learned was that what I think I need and what I really need are two very different things, and I found happiness in less things. As I progressively traveled, I kept losing things. I was like, okay, that's fine. The second thing I learned, chocolate really is better by the Swiss. I did take a bite out of that. And then I learned also that the prettiest mountains are the ones where I'm conscious. At 5,500 feet and I'm about to faint from lack of oxygen, it's kind of hard to know if something is pretty if you're not conscious. But most importantly, what I learned was that I have the power to do something. When I was traveling, found that lakes were drying up very, very rapidly. I managed to get a freelance photography. By now you're like, how many jobs has she had? So I did freelance photography for a colleague at the University of Chile. So she published a report a couple of months ago on Laguna de Azuleo. And in 2009, there was this massive lake. And what you see is within less than a decade, here I am standing in the middle of a lake basin where it's completely dry. And then I realized later on that glaciers are melting extremely rapidly. I've got my back to you because I'm actually crying here, because I was sitting on this edge of a lake, and every couple of minutes I would hear this thunderous cracking sound, and then a little bit of ice would just break off this massively beautiful glacier and just floated towards me and disintegrated right before my eyes, just melted before my eyes. It was so really moving, a really moving moment where I realized Greta is right, that we should really panic like the house is on fire. Even though we can't see it, it really is something that is happening, and I have seen it in different ways. And I realized that we actually have a responsibility we have an obligation to fight for a better world, for people who can't fight for themselves. And with that newfound knowledge, I decided I'm not going to, work in all these other areas that I worked in. And I went back to university to research how I can contribute to a better world, essentially. So I went to look for a PhD in conservation. So here we are today at the university. I'm at the University of Tasmania with the DEEP group and CABA. So DEEP is Dynamics of Eco-Evolutionary Patterns, and CABA is Centre of Excellence for Biodiversity and Heritage. And my project focuses on the drivers of biodiversity and endemism on volcanic forests of Eastern Australia. That's a mouthful of words. A lot of you are like, what are those words? So don't worry, I'm going to break it down for you. As Australia moved away from Antarctica, it probably moved over a hotspot. So the hotspot stayed still, Australia moved over it, and as it moved over it, we formed a number of volcanoes. We formed a number of volcanoes along the east coast. So this is potentially where the hotspot is now. And what we see is they're either more rhyolitic or more basaltic. So the rhyolitic stuff is the more white stuff, and then the basalt volcanoes are more of the darker stuff that you can see there. So I'm interested in looking at how the geological component of that could have driven biodiversity and endemism versus the climatic factors or the biogeographic factors. So what is biodiversity and endemism then? So biodiversity just means biological diversity. If something is biodiverse, it contains a diversity of biological components. So it has to be different from each other. That's what diverse means. So I have components such as angiosperms, then I have bryophytes, which are just ferns and mosses, and then I have orchids, which are angiosperms, and fungi, so just a range of diversity in terms of living organisms. What we tend to do is we tend to clear biodiverse areas and replace them with monoculture. So particularly, say, for example, in Southeast Asia, what we do is we clear our beautiful rainforests, and then we put something that's not very biodiverse in its place. And then the other component that I'm interested in looking at is endemism. I have actually written an article on what is endemism and why should you care. If you can just Google it, what is endemism and why should you care, by Annie. Or I can summarize it for you, and it's basically a taxon, for example, a species or a genus or a family is endemic to an area if you can only find it in that area. So it's basically related to how geographically limited it is. So it's important to notice that something can be endemic, like you can have particularly endemic areas that have a lot of species that can only be found in a very small region, but it doesn't necessarily mean it is biodiverse. So my goal is to find areas that are both biodiverse and endemic for conservation purposes. We do a terrible job in Australia protecting our forests. In Queensland, and I don't know about Tasmania, Margie might be able to tell you, but in Queensland, almost half of the reserves are private. So citizen scientists such as yourself are owning land and deciding to protect that rather than leaving it up to the state and government to protect our forests. So the goal is essentially to identify areas right across Australia to conserve. So that's my PhD. So what I wanted to do in continuing with the theme of how can I continue to inspire women into science, what I spent my grant money on is I bought maths and science books in English for a school in Kenya. Why did I target Kenya? Because what we know is that girl enrollments right across the world are not equal in terms of education. So for every boy that is in school, we see a drop in education enrollment in girls. So particularly in sub-Saharan Africa, we see that there's this massive drop. There's not 100% in girl enrollments, and then by secondary school and by bachelor level, there's a massive drop. And so I focused on Kenya. So my friend put me into contact with Elias, and I was about to move to Kenya before I got my PhD. And what the results that we can measure is that we managed to buy books and we gave them to all these adorable girls and boys in grade 5s to 8. But the results that you can't measure is that hopefully we've been able to provide them with skills that they can use. You know, I'm hoping that I'm investing in their future. Innovative thinkers. I'm hoping to invest in innovative thinkers. I'm hoping to grow innovative thinkers so that they can provide themselves with solutions for their future that they have to grow up with, essentially. So where am I going to go from here, and how can you help? Another thing that I'm doing in inspiring women in STEM, in inspiring more women into STEM, is I'm running a SciPub project. I started this in 2019 because what I noticed when I was starting to learn Python was that there's not a lot of women who are in programming at all, and it was a very male-dominated field. It was very intimidating to go up to, a room full of men and going, I don't know what to do here. If I had a Python problem, I didn't ask, essentially. And I wanted to change that. I wanted to make a really encouraging, inclusive, beginner-friendly environment where anybody could learn Python. So the SciPub project aims to introduce complete beginners. Anybody who's interested can learn. And we used to be in person, but we're now online because of the pandemic, and we're hoping to go back to being in person but we will continue to maintain an online presence. Everything we do is free and open source, so you can find everything that we've done so far on GitHub, and you can email me, SciPubProject@gmail.com. And take-home message is, please continue to stay curious. You're here because you're curious about science, you're curious about the world, how it works and everything, so please continue to stay curious. The next thing is conservation is key. We can't just be very irresponsible people and just clear really biodiverse property, biodiverse landscapes, and then just pay some third developing country, to plant something. Because in the process of clearing, we're making something extinct. We're destroying functions in forests that don't get replaced when you just plant trees somewhere else. So conservation is key. And the third thing is, please continue to care. Continue to care about inequalities, about developing countries, about girl enrollments, about climate change and children of the future. And, 3 things.
Transitioning over to our next speaker. But now's a good time for a quick question.
Yeah.
Can I ask what hotspots are? Like when you said it.
Oh, I'm sorry, yes. So in my thesis, I first assumed everybody would know what I mean. And I've had to go back and do the following hotspot. And I've had to go volcanic hotspot versus biodiversity hotspot. So there's actually 2 different types of hotspots. A volcanic hotspot is basically an area in the mantle that is generating more heat, and then a little bit of ruptures into the asthenosphere, and so the hotspot itself is just an area of heat. So volcanic hotspot is an area of heat, whereas biodiversity hotspot is an area where it's much more biodiverse. Yeah. Yeah.
If the hydrochloric acid can just dissolve everything, why after the spores?
The hydrofluoric acid is targeted. I only deal with a tiny amount, and what it does is I'm actually standing over it and I watch it as it dissolves silica content, mineral content, and as soon as I notice that it's dissolved, as soon as it turns a particular color, and then I take it off straight away. Yeah, so I protect this whole.
Meg, are you there?
Yeah.
Hey,
What's
Meg.
the second M in STEM?
Sorry?
What's the second M?
The second, yeah, so recently, there was a point when it was STEAM, STEAM, but right now it's STEM, so science, technology, engineering, mathematics, and medicine.
Works?